So we are starting Chapter 3 for Chemistry 1. Chapter 3 is titled Atoms, the Building Blocks of Matter. And this video is on Section 3.1, the Atomic Theory. So we're going back in time a little bit. So we first have to remind ourselves, what is the law of conservation of matter or mass? Those two words can be interchangeable in this. We talked about this in Chapter 2 and Chapter 1. Matter cannot be created or destroyed, only changed. And remember, that change can either be a physical change or a chemical change. The new law we need to talk about is the law of definite proportions, which says a chemical compound contains the same elements in exactly the same proportions by mass, regardless of the sample size. So what does that mean? Well, if we look at an example, NaCl, which is sodium chloride table salt, is always composed of 39% sodium and 61% chlorine. So it doesn't matter if you have a grain of salt or a whole salt shaker of salt. It is 39% sodium and 61% chlorine. It's a definite proportion that does not change. Same thing with water. Water is H2O. You always have 2 hydrogen atoms and 1 oxygen atom. That is water. It's definite. If you had anything else, you wouldn't have water. You'd have something different. And the final law we have to talk about is the law of multiple proportions. So multiple means many. So this law says elements may combine in greater than one way, but always in small whole number ratios. So what does this look like? Well, elements may combine in more than one way. So we have carbon and oxygen, CO, and then we have carbon and oxygen, CO2. Same elements, just in different amounts. In the first compound, we have 1 carbon and 1 oxygen. That is carbon monoxide. It's a deadly gas. In the second compound, we have 1 carbon, 2 oxygens. That's carbon dioxide. That's what you exhale and you breathe out. It's around you all the time. Same elements, but different proportions. The law of multiple proportions. Same thing with, if you look at water again, water is H2O, 2 hydrogen, 1 oxygen. If you take H2O2, 2 hydrogen and 2 oxygen, now you have hydrogen peroxide. You can drink water, H2O, and be fine. You cannot drink hydrogen peroxide and be fine. Same element, multiple proportions. So next up, we need to talk about John Dalton's atomic theory. John Dalton was the first person to come up with the atomic theory. So thinking about the 3 laws we just looked at, here's his atomic theory. His first point was that all matter is composed of very small particles called atoms. And this is a theory. This is just what he was speculating at the time. His second point is that atoms of the same element are identical in size and mass. So if they're the same element, they should have the same size and the same mass. He also went to say atoms of different elements are different in size and mass. So different elements should have a different size and a different mass. His third point was that atoms cannot be created, destroyed, or divided. His fourth point was atoms of different elements combined to form compounds. And his last point was that in a chemical reaction, atoms may either combine, come together, separate, pull apart, or just rearrange to make new compounds. So that was his atomic theory. Very first one, very old. Now let's go back and compare to the modern atomic theory. So I'm just going to do that on the right side of your screen. So comparing John Dalton's theory on the left, which I've italicized, to our modern day theory on the right. This is still true. All matter is composed of small particles called atoms. So he was correct there. We know more about the atom than we did in his time, but he was on the right track. All right. His second point was about identical elements having the same size and mass, different elements having different size and mass. It is still true, but we know now that atoms of the same element may have different masses. The second part is still true, but the first part is a little bit iffy, and those are called isotopes, which we'll talk about later in the chapter. His third point was basically talking about the law of conservation of matter. So yes, you cannot create or destroy matter, but we now know that you can divide them. And that's what nuclear fusion is, and fission. So we've updated that. Number 4, atoms of different elements combine to form compounds. That is definitely still true. And number 5, you get chemical reactions by combinations or separations or rearranging of atoms. That is still true. So overall, he was pretty correct given the limited technology he had. And that is the end of this lecture, 3.1.